2.4, exponential function manipulation. All right, let's do this.
The properties of the exponents that you learned in algebra can also be used to manipulate, rearrange exponential functions in an equivalent form.
All right, fantastic. So this is first called a product property. So when we have like bases, we add the exponents together. Okay, so when multiplication happens with like bases, you add the exponents. Good? Cool. So if it's addition, you can break them up, and we can split them up that way too, if we were to go backwards. All right? So addition in the exponent means multiplication with our bases. Good? All right, cool. So this is called the power property. All right? And so this is what you think of as a power to a power. And so when you have a power to a power, you have multiplication with those exponents. Okay? So you have a power to a power, you do what? You multiply. And if multiplication is going on, so if I were to break out this 2 to the power of 3x, this is really like 2 to the power of x cubed. Or you could think of it as like 2 cubed to the power of x. All right? Those are the same things. All right? Then negative exponents. All right? This is my childhood, and if my mother is listening, that's fine. All right? Does anybody get yelled at home? Anybody? Anybody at all? Good. Your parents care about you if you get yelled at. Okay, they do. All right. And so every now and then, when I grew up in Ohio, we had a 3-story home because that's what most houses were. So you had a basement, you had a main floor, and you had like where your upstairs was, which is basically your bedrooms. All right. That's really how things worked in Ohio. And so if you ever got in trouble, or when I got in trouble, my mom would always be like, "Go to the basement," and I can still hear it, and I talk to my mother every single day still, and I love her, however, and she loves me. But if you got in trouble, you had to move stories, all right? And that's how negative exponents work. So, for instance, if I have a negative exponent, so if I have x to the negative third, guess what happened? It got in trouble, so where did it go? In the basement. And so now it becomes positive, all right? And so that's how it works. And so if I do it differently, if I say it's like 1 over 2 to the power of negative x, well, where the crap did this one get in trouble? It got in the basement. It got in trouble in the basement, so where does it go? Upstairs to your room, all right? And so I always had to change stories. And so this is really just the same thing as 2 to the power of x, all right? Because it moves stories, and then it becomes positive, all right? So that's how I think of negative exponents, all right? All right, let's play. Connell, keep reading. You're doing great.
The same exponent rules can be used when working with horizontal transformations of exponential functions. Example 1. Determine the horizontal transformations of each of the following exponential functions.
All right, so we're going to talk about horizontal transformations. So we did this in Unit 1. It's Unit 1, Section 12, if we remember. So if it's inside my function, if it messes with the x, it kind of does the opposite of what you may think. And so if I add 2 to this function, what's actually happening? Do what? Okay, what does it mean subtract 2? Which way does it move? It moves left. So this one moves left 2. That's our layman terms, all right? And so what we really want to call it is a horizontal translation of what? Negative 2, all right? Layman's terms is it goes left 2, which is good. That's how you should think. But it's a horizontal translation of negative 2. All right, let's do the next one. So then I have 2 to the power of 3 times x. All right, 3x. And so what does this do? It's a horizontal dilation of what now, Connell?
1/3.
Of 1/3. Exactly. Good. All right, let's look at this next one. So now I have 9 to the power of x over 2. All right, and so what's this one again? It's a horizontal dilation of what? Of 2. All right, because this is the same thing as 1/2 x. All right. All right, this next one, I have 5 to the power of x minus 1. Well, what's this one do? In layman's terms, what's this do? It goes right 1. All right. However, what do we actually say that is? It's a horizontal translation of what? Of 1. All right, beautiful. All right, you're doing great, Connell. Keep going.
Now let's re-examine the exponential function from example 1. then see if we can use our exponent properties to rearrange the function to an equivalent form. We can use the product property in reverse to show that.
All right, so if we have 4 to the power of x plus 2, all right, so I have addition going on, so what's really happening? Multiplication with the bases, all right? So I can break this down as 4 to the power of x and then times 4 to the power of 2. Everybody see how that happened? And so we can evaluate 4 squared, and 4 squared is what? 16. And so now I have 16 times 4 to the power of x. First of all, I had this happen earlier today. Are you allowed to do 16 times 4 to the power of x? Like, are you allowed to do 16 times 4 and then raise it to a power of x? Is this 64x? Is this equal? No. All right, that kills kittens. We don't want to do that, and so please don't. All right, and so now we have this as our equivalent form. So this is the same thing as that. However, do they look the same? No. And so let's keep going. You're doing great.
When we rewrite the exponential function in this way, there is no longer a horizontal translation. But now we have a vertical dilation by a factor of 16.
All right, beautiful. Okay, so now if you look at this thing, does it have a horizontal translation? No. All right, so this A thing out front is actually a vertical dilation. All right, and so this is actually known as our what? Does anybody remember? It starts with an I, an initial value. All right, and so this is an initial value of 16. So like we did the other day, this is an initial value of 16. It's the same thing, because what's an initial value? It's when x is equal to what? 0. And so if I were to substitute in 0 right here, guess what I'd get? 0 plus 2, which is 2, and then 4 to the power of 2 is 16. And so that's where this came from. All right, so these are equivalent, they just look different. All right, all right. I'm not worried about the important idea. We kind of just discussed it. So instead of a horizontal translation, now we have a vertical dilation. All right. Asher's going to read. He's looking forward to it.
Every horizontal translation of an exponential function, parentheses f of x equals b to the power of h, x plus h, is equivalent to a vertical dilation of the exponential function that where a equals b to the power of h.
All right, example 2.
Each of the following exponential functions has a horizontal translation. For each, write an equivalent representation that has a vertical dilation and no horizontal translation.
In the form of a, b to the x. All right, so all of these, if you look at a, b, and c, they have horizontal stuff going on. All right, and so we're going to take away the horizontal stuff, and now we're going to talk about it with vertical. So we're just manipulating. All right, women are good at it. Guys, let's catch up. All right, so here we go. So if I have 2 to the power of x plus 3, okay, if I break that down, if I manipulate it, then I'd be with what? 2 to the power of x, and then times what? 2 to the power of 3. Yes, we are going to call it that in a sec. And so now, what is 2 to the power of 3? 8. And so this is the same thing as saying 8 times 2 to the power of x. All right, and so our original and that are the same. All right, so we're breaking it down. All right, and so let's look at part B. So now I have 3 to the power of x minus 2. And so now, how could I break that one down? 3 to the power of x, and then 3 to the power of negative 2. And so what is 3 to the power of negative 2? That's really where it got in trouble. So where's it go? In the basement. So this is the same thing as saying 1 over 3 squared times 3 to the power of x. Everybody follow me on this? So what is 1 over 3 squared? 1/9. And so g of x can be simplified as 1/9 times 3 to the power of x. All right. All right, let's look at the next one. So now I have k of x is equal to 4 times 3 to the power of x plus 2. And so this one, how can we break that one down? Good. All right, and so now we have 3 to the power of x, and then 3 to the power of 2. And so what is 3 squared? 9. 9 times 4 is 36. So k of x could be written as 36 times 3 to the power of x. All right, and those are the same now. All right, so now let's look at power property of exponents. All right, so again, power properties of exponents. All right, when you have a power to a power, what do you get to do? You what? You multiply them. And so if they're multiplied, we can put them into a power to a power. Okay, good? Cool. Let's go. So which of the following is equivalent to the form of 9 raised to the power of 2x? And so 2 and x are being multiplied. So how could I break that one down? 9 to the power of 2 and then to the power of x. Okay, I break them that way because it's a power to a power. All right. And so what is 9 squared? 81. And so now this is equivalent to y is equal to 81 to the power of x. All right, let's look at example 4 now. All right, and so in example 4, which is equivalent to 9 times 4 to the power of x. So can we simplify this 9 times 4 to the power of x very well? Can we simplify it much at all? No. And so this is where I would do your answer choices to see which one looks like that, instead of trying to mess with that to see which one looks like this. Make sense? All right. And so this is where I would kind of use these to guide me to get there. All right. Because sometimes we have to do that. All right. So let's look at A. Let's just go in order. And so I have 3 times 16 to the x over 2. And so this is really what? 3 times what? 16 to the... So now I have 16 to the power of 1/2 and then to the power of x. So what is 16 to the power of 1/2? 4, because it's a square root. All right. And so now I end up with 3 times 4 to the power of x. Is that what we wanted? No, so it's not A. So now let's look at B. And so on B, how do we break down this 16 to the power of 2x thing? 3 times what? 16 to the power of 2 to the power of x. Well, what's 16 squared? 256. Good job. All right, and so now we have 256 to the power of x. Is that what we want? No. So now let's look at C. And so now we have 9 times 16 to the power of x over 2. And so x over 2 is the same thing as what again? 1/2 x, right, Robert?
Yes, correct.
Right, good. All right, and so now we end up with what? 9 times 16 to the power of 1/2 to the power of x. And so what is 16 to the power of 1/2? 4. So now I have 9 times 4 to the power of x. Is that what we wanted? Yes. Let's just make sure that D does not work. It won't. However, so this one, we'd have 9 times what? 16 power of 2 to the power of x. And so this one would end up being 9 times what? 256 to the power of x. All right. So if you have a power to a power, you do what? You multiply. All right. If you have powers that the same bases that are multiplying, what do you do to the exponents? You add them. When you have a negative exponents, what should you do? Move them to the basement or move them to their bedroom. All right. And so anyway, they have to move floors. All right.